Okay, let's look at data for Lab 3. Lab 3 is muscular strength, power, and endurance. Hopefully you've watched those videos already. Looking at page 19 in your lab manuals, under procedure for hand grip dynamometer, the MVC, as you'll see when you look at your scan pages, is 50.5 and 51.5 for Sam's second trial. So Sam's maximal voluntary contraction was 51.5. I need you guys to figure out 20%, 50%, and 80% of that number, and you will scan and send that into me. Email that into me. Next page is page 20. For the trial for the 20%, Sam went 4 minutes. 50%, he did 2 minutes and 15 seconds, and 80%, he was able to hold for 51 seconds. Number 5 was a rhythmic contraction. So what Sam did is rhythmically he'd go to 80% and he'd release the tension, then he'd do it again. And he did that over and over until he could not hit 80% of his MVC anymore. At that point, we stopped the stopwatch. His time for that was 32 seconds. Number 6 is sustained MVC. And what we did there, and you saw this on the recording, is Sam held his MVC for as long as he possibly could, up to 30 seconds. And we measured every 5 seconds, we measured where he was as far as his contraction strength. So when you look at the time in seconds in the left-hand column, and then the force generated in the right-hand column. So what that means, at 5 seconds, Sam was generating 48, at 10 seconds, 47, at 15 seconds, 43, and as he fatigued, that number dropped. What I need you to do is calculate his fatigue index. The equation is given. Maximum force minus minimum force divided by the time of the minimum force, subtracting the time of the maximum force. So do that calculations. There's no units for fatigue index. Write out your numbers and then scan and email that into me as well. Flip over to page 23. On page 23, you have vertical jump data sheet. At the top, you see reach height. Sam's maximum jump height was 9 feet 4 inches. 9 feet 4 inches. So take his jump height, subtract his reach height. That will give you his vertical jump. Okay. So once you have his vertical jump, you will put that down in the equation below. That's going to be in inches. You need to convert that to meters. The conversion from inches into meters is given. So you take your inches, multiply by 2.54, then multiply that number by 0.01, and you're going to get meters. Sam's body weight was 77.5 kilograms. And what you're going to do then is calculate Sam's absolute power output and his relative power output. So those two equations are given. If you look under equations, absolute power output equals body weight in kilograms times jump height in meters times gravity, which we know gravity is 9.81 meters per second squared, divided by the time that it took him to jump. That time is given. Right after that is relative. So if you want to separate those two, those are on the same line, so that's a little bit confusing. The equation for relative power output is given. That's body weight in kilograms times jump height in meters times gravity divided by time. The time constant, if you look down below in the group results, is 0.25 seconds. So we use 0.25 seconds for the time on both of those equations. Once you calculate that, you again need to divide by body weight, and that will give you relative power output. So we need absolute power output, and then if you take absolute power output and divide by Sam's body weight, that will give you relative power output. So absolute or total power output is going to be in watts, and relative power output is in watts per kilogram. So once you have that, do that equation. You can scan that in and email it to me, and I will get that as well. And then there'll be questions on this lab for you to do under assignments, and you'll be able to turn those into me as well. So thanks for your time. We'll talk to you soon.